to be looking at correlation and regression, in particular a linear correlation. So you can see here with these three pictures, we've got matched pairs of data, and we've taken those matched pairs and considered them points, and we've graphed these points. And so when you graph the points, you can see here that there is no relationship at all. It's completely normal, completely random. Now, with these two, you can see a relationship. And it appears that these are coalescing around a line, but they're very loosely coalescing around a line. Whereas here, they tend to be coalescing tighter around a line. They're in closer. And so both the red and the blue, those points do have a correlation. The red is a positive correlation because the slope of this red line is positive. When you move from left to right, you're going uphill. And the blue line's a negative correlation because as we move from left to right, we're going downhill. Now, there is a number R that will measure how good a linear correlation you have. The number R is always a number between -1 and +1. Now, the closer you are to the extremes, the stronger your correlation gets. And of course, the closer you get to the middle, which is 0, that indicates something completely random. So you can see here, no correlation, R is 0. With this one, you can see that there is a correlation. Look at that number. It is very, very close to -1. So it's a very strong correlation. Whereas this one, there's still a correlation. That number is close to +1, but it's 0.851, not as close as -0.965 is to -1. So this one's the stronger. This blue one that I'm going to draw is the stronger of those two. Okay. So R is going to be what we use for our sample data. And then that's not a P here, this is rho. Rho is going to be your linear correlation for your population. So for everything, okay? Now, to get R, you can get your calculator to do it for you, but you must have your diagnostics on. So the way you get your diagnostics on, to show you what R is, you press the second button and the 0 button to get into the catalog, and then alphabetically you go down here to diagnostics and you want diagnostics on. There it is. Press enter and enter again. Okay. Now, when we're doing hypothesis testing with correlation and regression, the null hypothesis will always be that your population correlation coefficient is 0. So everything's random. There's no linear correlation at all. And your alternative hypothesis is going to be that so this is a rho, not a P, that your correlation coefficient for the population is significantly different from 0. So there's some kind of linear correlation going on. You're going to find R from the calculator, and you're going to take its absolute value, and you're going to compare it to the critical value. You will get the critical value from a table, and different textbooks have different ways that they present the data, but you will get your critical value from a table. So here's the test. If the absolute value of R is bigger than the critical value, you will reject the null hypothesis, and you will conclude that there is evidence of a linear correlation. If the absolute value is not greater than your critical value, then you will fail to reject the null hypothesis, and you won't have enough evidence for a linear correlation. So, what happens if you're asked to make predictions on paired data? Well, you can only make predictions if you have a linear correlation. So if you do this lin reg in your calculator, it always gives a regression formula. So for that line of best fit. But you don't always use it. You only use it if you have evidence of a linear correlation. If you don't have evidence of a linear correlation, you don't use the regression formula. And the best predictor you can have is your average value for your Y values. Okay, we're going to see this. So do not use the regression equation that your calculator gives you if there's not a linear correlation. Okay, so straight into this. This is paired data. So an employee comes in and the employee takes a dexterity test and a productivity test. So this first employee scored 46 on the dexterity test and 23 on the productivity test. So if a person comes interviewing for a job and they're given a dexterity test and they score 62, what would you expect them or predict them to get on their productivity test? Okay, so the first thing we're going to have to do with this paired data, my dexterity values are going to be my X values and my productivity values are going to be my Y values if I think of these as points. Okay, and so I'm going to put the first row in list 1 and the second row in list 2. So I need to come here to stats. If I press enter, I've got some data, old data, and I need to get rid of that. I can't just overwrite it. So I'm going to press stat, and I'm going to come down here to clear list, and then second 1 comma second 2. Okay, and now I'm going to press stat and enter, and I'm going to come here to list 1, and I'm going to enter my X values. Okay, so what I'm going to do now is I'm going to pause the video. I'm going to enter this off camera and then I'm going to come back. Okay, so I've entered my list and I've double checked them. All right, so let's look at the scatter plot. I'm going to come here to Y equals. If you have any old data in there, get rid of it. And then press second Y equals, then press enter. And where it's flashing there, press enter. I want my plots on. The default is scatter plot. The default is X list was list 1, Y list was list 2. And I'm going to click on zoom and then the number 9. Now there is my that looks very much to me like there is a linear correlation going on. It does look like it. Okay, but I can't just eyeball it and say. I have to prove it. Okay. So what I'm going to do now is I'm going to click on, I'm going to get out of here, second mode. I'm going to click on stat, go over to calc, and then come down here to lin reg. And my X values have been in list 1, Y values in list 2, leave frequency list blank. I can store my regression equation. I click on vars, scroll over to Y vars, click enter, then enter again. I've stored it in Y1. So if you press Y equal, it will be stored in the first formula there. And then come down here and press calculate. So my null hypothesis, my null hypothesis is that the correlation coefficient for the population is 0, which means no linear correlation. And my alternative hypothesis is that it's somehow different, significantly different from 0. So there is some kind of linear correlation. Now I'm going to look at my absolute value for R, and then I'm going to compare it to the critical value. So for R, I'm going to take that to 3 decimal places. R is 0.979, so the absolute value of R is 0.979. Now what is the critical value? Well, I need to know N and I need to know alpha. This tells me alpha is 0.05, and then N is the number of pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to get my critical value now from that. I have to use a chart. Okay, so alpha is equal to 0.5, so I'm going to circle this column. And n is equal to 10. That's my number of pairs. And we see here that they intersect at 0.632. Okay, so I'm going to come back down to my problem. Actually, I'm going to come here. So is the absolute value of R greater than the critical value? Yes, it is. If it is, we reject the null hypothesis. So now let me come down here where we... This number is bigger than that number. So the absolute value of R is greater than the critical value. So we reject the null hypothesis. And we conclude that there is a linear correlation, which is what it looked like on the scatter plot. Now, since there is a linear correlation, we are going to use the regression equation to make the prediction. So, the regression equation is, we write it with the y hat, is equal to A. And the convention is, if you're doing this by hand, to take it to 4 places. Plus B is 0.8118. That's if I write it like this. So if a person's interviewing for a job and their dexterity score is 62, so if X is 62, what is the predictor for their productivity score, their Y value? And you would just put in a 62 there. Or you can get your calculator to do it for you directly, which I'm going to show you in just a sec. So 0.4633. Okay, I have an extra 6 in there. Times 62 plus 0.8118. All right, and you take it to 1 decimal place more than the chart. So if they made a dexterity score of 62, then it would be predicted that their productivity score would be 29.5. Now, how can I get my calculator to do the whole thing for me? I stored that formula in its entirety in Y1. So I click vars, I go to Y vars, press enter, then enter again, and I want that formula evaluated at 62. So I put 62 inside parentheses. And it's the original formula, so it is more accurate, but it's still, if I take it to 1 decimal place, I get the same answer. Okay, so either way, whatever your professor prefers, however you want to do it. Okay, let's go to this second one. A study was conducted to compare the average time spent in a lab each week compared to the grades you get in the class. So this first student averaged 10 hours in the lab every week and ended up getting a 96 in the course. The second student spent an average of 11 hours in the lab each week and got a 51 in the course, and so forth and so forth. So the first thing we're going to have to do is put these into a list 1 and list 2. So I'm going to come here at y equals, I'm going to clear out that old formula. I'm going to clear out my old list 1 and list 2. So second 1, comma, second 2, and I'm going to put this stuff in here. So stat and enter, and so I'm going to have, oops, I need to go over to list 1. There we go. Now 10, 11. Okay, and again, I'm going to put this on hold while I do my 2 lists. Okay, so I've got my list there. Let's have a look at the scatter plot and see if we can kind of get a feeling of where this is going. So I'm going to press second y equals. I'm going to press enter. Then I'm going to press enter again because I want those plots on. And everything else is default. So I'm going to do zoom and then the number 9. No, I do not think that's showing any kind of a linear correlation. Okay, so my gut feeling is there's not going to be a linear correlation. So let's actually get out of here and let's ask it to do linreg. So I'm going to go over here to calc. I'm going to come down here to linreg. And I've got my X list in list 1, my Y list in list 2, frequency list, leave blank. I'm not going to store the regression equation because I don't think we're going to use it. You only use it if there's a linear correlation. So I'm going to click on calculate. Okay, so remember, what is the null hypothesis? The null hypothesis is that your population correlation coefficient is 0, which means there's no linear correlation. And the alternative hypothesis is that your population correlation coefficient is significantly different than 0. And so you do have some linear correlation. Now we're going to compare the absolute value of R to our critical value. So R here is minus 0.335. So the absolute value of that is going to be positive 0.335. And now we need to get our critical value from our chart. Oops. And what I need to know for the chart is what N is. Okay, so N is the number of pairs that we have. And there is 1, 2, 3, 4, 5, 6, 7, 8 pairs. And once again, we're told that alpha is going to be 0.05. Okay, so let's get our critical value from the chart with that. Okay, so N is 8. And my alpha is 0.05. And they meet up at 0.707. So that's my critical value. So now I'm going to get back to the problem. And my correlation coefficient for my sample, the absolute value of it, is smaller than my critical value. And the test was, if the absolute value of your correlation coefficient was smaller than the critical value, you fail to reject. You do not reject the null hypothesis. And the conclusion is that there's no linear correlation. So to make a prediction, we do not use the regression formula. So a student spends 13 hours in the lab per week. What is his predicted course grade? His predicted course grade is the average of those grades. Now I can get the calculator to do that for me. So what I'm going to do is I'm going to go to stat, come here to calc, and then do 2 var stats with list 1 and list 2. And then I want the average Y value, so 66.75, but it really doesn't mean anything. So if a student spends 13 hours in the lab, the best predictor we could make is that he would get a 66.8 if I take it to one place. But it's not meaningful at all because there was no linear correlation and we could not use the regression formula for that. Okay, so that's one example of each. I hope that gives you enough variety there to see how that was done, and I'm going to stop the video now.